There is a possibility that the Arctic could potentially lose its ice cover and become devoid of ice within a span of 10 years. Greetings, everyone. Today we will delve into a fascinating topic regarding the potential future of the Arctic. A recent study conducted by the University of Colorado Boulder has shed light on the possibility of the Arctic experiencing summer days with minimal to no sea ice in the coming years. Surprisingly, the research indicates that the first ice-free day could occur much sooner than previously anticipated, possibly over a decade earlier. As we fast forward to the middle of this century, it is highly likely that the Arctic will witness an entire month without any floating ice during September, which is the time when the region's sea ice coverage is at its lowest. Looking even further ahead, towards the end of the century, the ice-free season could extend for several months each year, contingent upon the emission scenarios that unfold. So without any further delay, let us dive right into our discussion. According to the University of Colorado Boulder, a recent study suggests that the Arctic may experience summer days with minimal sea ice within the next few years. According to a study published on March 5th in the journal Nature Reviews Earth and Environment, new findings indicate that the Arctic may experience its first ice-free day even earlier than previously anticipated. Previous projections primarily focused on when the region would be devoid of ice for a month or longer, but this study suggests that the first ice-free day could arrive over a decade sooner. Importantly, this trend holds true regardless of the emission scenarios considered for the future. In the foreseeable future, specifically by the middle of this century, it is highly probable that the Arctic will experience a complete absence of floating ice for an entire month in September, which is the time when the sea ice coverage in the region is at its lowest. Looking even further ahead towards the end of the century, the duration of ice-free conditions could extend to several months each year, contingent upon the emission scenarios that unfold. For instance, if emissions continue at a high rate, following a business-as-usual trajectory, it is conceivable that the northernmost part of our planet could consistently lack ice, even during certain winter months. In the perspective of scientists, the absence of ice in the Arctic does not imply a complete absence of ice in the surrounding waters. According to researchers, the Arctic is considered devoid of ice when the ocean's ice coverage falls below 1 million square kilometers, 386,000 square miles. This measurement accounts for less than 20% of the minimum ice cover observed in the region during the 1980s. In more recent times, the Arctic Ocean has experienced a minimum sea ice area of approximately 3.3 million square kilometers in September. In her pursuit of understanding the future of sea ice, Alexandra Jahn, a fellow at CU Boulder's Institute of Arctic and Alpine Research, and an associate professor of atmospheric and oceanic sciences, embarked on a comprehensive analysis of literature pertaining to sea ice projections. Additionally, Jahn and her colleagues examined data on sea ice coverage derived from computational climate models in order to evaluate the potential daily changes in the Arctic. On average, researchers discovered that the first day when sea ice coverage falls below the 1 square kilometer threshold happens 4 years prior to the monthly averages, but it could potentially occur as early as 18 years beforehand. According to Jahn, accurately predicting the occurrence of the first ice-free conditions in the Arctic, as reflected in the daily satellite data, is crucial for effectively conveying scientists' expectations regarding the region. Under all emissions scenarios, the team has projected that the Arctic Ocean may experience its first ice-free day between the 2020s and 2030s, specifically in late August or early September. According to Jahn, the primary cause of sea ice depletion is the emission of greenhouse gases. As the coverage of snow and ice diminishes, the ocean absorbs more heat from sunlight, intensifying the melting of ice and the overall warming of the Arctic region. The decline of sea ice has notable consequences for Arctic wildlife, such as seals and polar bears, which heavily depend on sea ice for their survival. Moreover, there is growing concern among researchers that the warming of the ocean may result in the migration of non-native fish species into the Arctic Ocean. The potential effects of these invasive species on the local ecosystems are still uncertain. the coastal communities are at risk due to the loss of sea ice. According to Jan, sea ice plays a crucial role in mitigating the effects of ocean waves on the coastal land. As the sea ice diminishes, the size of the ocean waves will increase, leading to coastal erosion. According to Jan, the occurrence of ice-free conditions in the Arctic is unavoidable. However, the frequency of these conditions will depend on future levels of emissions. If emissions follow an intermediate scenario, which aligns with the current trajectory of society, the Arctic may only be ice-free during the late summer and early fall months, specifically from August to October. Conversely, if emissions continue to rise at the highest scenario, the Arctic could experience ice-free conditions for as long as 9 months by the end of the century. According to Jan, the Arctic would undergo a profound transformation, shifting from its current white summer state to a blue Arctic. Therefore, even if we cannot prevent ice-free conditions, it is crucial to minimize our emissions in order to prevent prolonged periods without ice. Fortunately, Arctic sea ice has the ability to bounce back swiftly if there is a cooling of the atmosphere, which is a positive development. According to Jan, while the ice sheet in Greenland formed over thousands of years, melting all the Arctic sea ice and developing a method to extract CO2 from the atmosphere in the future to counteract warming would result in the sea ice replenishing within a decade. The funding for this project was provided by the US National Science Foundation, the Alexander von Humboldt Foundation, and NASA. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.